And I'm just going to pull up, let's see, 6.1, 6.2, 6.3. And let's see what we got. Structured resources. 6.1. 6.2. And 6.3. That's good enough for today. And all I do is just look at the slides, and I think we're just doing higher degrees. And what to do with higher degrees, we're going to have to use a little bit of long division. AX cubed, cubic function, extreme, hidden behavior. Okay. Let me go into 6.2. Engine behaviors. Okay, there's engine behavior. Okay. Okay, fitting a line. We're still fitting a line. So, okay. Let me check out this third section. Because it looks like to me, we don't have anything but graphing drills first three sections. Let's see what this one looks like. Okay, yep. Okay, the good news is the first three sections are pretty much graphing. Okay, so we're going to be playing on the calculator a good bit. So let's go ahead and pull up that last section of PowerPoint, and let's go to it, 6.1, and pull up the handy dandy PowerPoint and 6.1. So when you have a problem, and here's one right here, so x cubed plus 27x, so write that down. Y is equal to x cubed minus 27x. Well, you already know what it looks like because it's a family of graphs. So what do you mean? Well, your family of graphs that you learned tells you that it's a cubic function. So it's going to look some form like that. It's going to be some form of that. The ending behavior is right here. This is called ending behavior. Okay, so a cubic function, a 5th degree, a 7th degree, a 9th degree, and so on. Odd functions, your ending behavior is going to be in the what direction? That means I want y'all to say something.
Priority 1 message coming in on secure.
The opposite direction, okay? So you need to write that down because that's a test question. It's not only a test question on my test, it's also a standardized test question. So if you have an odd function, the ending behavior is going to be in the opposite direction. Now, what's the difference between an x to the 5th and an x to the 7th? Well, right in here, I'd say from about right in here, I'll do this in green. This area right in here is affected by these coefficients, these exponents. So the higher the exponent, the more this flattens out. So you may get one that looks like this. And that may be an x to the 5th. And then you may get one that looks like this. And that may be x to the 7th and so on. So the degree has a lot to do with how flat this middle part is. Okay. Of course, you're going to be doing this on the calculator. So let's go to the calculator. Now, what should you be able to do with the calculator? You should be able to do everything with the calculator. For this test, for the first 3 sections, it's all going to be nothing but calculator. So let's clear this and clear this. And let's do y is equal to clear, clear. Let's make sure that the stat plot is turned off. And y is equal to, and I'm going to do this in black. So let me just go to the black.
Priority 1 message coming in on secure channel.
I want to go with black. And I want to make it a dashed because I'm going to do the basic model. And that's going to be x cubed. X cubed. There's your basic model. There's your parent graph. And then this one is going to have a little bit more of a saddle because you got another x. Now, anybody knows what a saddle is? Hopefully, y'all know what a saddle is. It's what goes on a horse. It's the saddle part. The more x's you have, the more it's going to loop. Not flatten, but loop. And you're going to have a max and a min. So let's do that in pink or magenta. X to the 3rd minus 27x. Did y'all see the note about 130? Yes or no?
No.
Yes.
Yes.
Well, if you didn't, I'll show it to you right quick. I am teaching Math 130 next semester. And I want you to write it down. There it is right there. 130, 48, 180. The reason I brought that up is because the being able to ascertain these lines is used in calculus a good bit, and that's what made me think of the, so 48, 180. And a lot of people say, well, I'm not going to take Hubert again. I'm going to take somebody else. Go ahead. Hopefully I won't see you in a couple of semesters.
I'm already in it.
Your alternatives are not that great. Say again?
I'm already in it.
Good.
Yeah.
Good, good, good.
See it.
There's one or two of y'all that's saying, oh, well, I can take it under anybody. Famous last words. All right, so graph and stat. Let's go with fit. Or zoom fit. That looks weird. Let's go with zoom standard. Okay, so there is your graph, family graph, and you can see this thing is going crazy. Let's see if we can adjust the window a little bit. I'm going to zoom out a little bit. And zoom out. I'm not going to be able to. I'm going to have to adjust the window. I hate adjusting the window. Yeah, see, there it is right there. I'm going to do a zoom box, and I don't know if that'll work or not, but hopefully it'll work. Give you a little bit of a better. Do not hold the button down, whatever you do.
Are you in it now?
Mm-hmm.
What?
Really? Wait,
It's the
which
worst.
class is this? Like what subject?
My math.
Oh, okay. Math. Yes.
It's just so.
You need to check those microphones there, buddy. Glad y'all wasn't getting into intimate conversation. Be like that guy with his underwear on. That gum.
He has his
Is this on the Zoom call?
something.
Oh,
I turned the volume down because it was.
Okay, yeah, I believe you need to mute it, bud. All right, there we go.
And I should do. I have one.
There you go. And see
somewhere
how it.
left on
See how the
previous
saddle.
Mhm.
See how the saddle is formed here,
44.
and it's not here.
uh-oh.
So I should probably.
Okay.
That's like a 70
Word.
before the grade goes in and affects my grade. And that'd be cool. So I get a cool pen.
Those are always so fun. I always try to push them all down at once.
Mute your mic.
Thank you.
One's gotta.
I'm trying to mute it, but I can't mute it. I don't know why.
I'm gonna text him so he can.
I'm trying to get there. Hold on. There, now it's muted. All right. Sorry about that. Okay. So now let's get the max and the min. Here's the min. Here's the max and the min. There's the max. There's the min. And we need the X-Intercepts. Max, min, X-Intercepts. Write that down. Also, I'm going to put this in red. What else do you need beside the max and the min? You need the max. You need the min. That's also local max and min also, which means like the secondary max and the secondary min. You also need the X-Intercepts. And you can actually get the Y-Intercept by either looking at the table or, it's 0, 0 because, you plug in 0 for X, you get the Y-Intercept. And 5, how many turns? N minus 1 turns. What does that mean? Well, X to the third. What is 3 minus 1? 2. You got 2 turns. That's how you figure out how many turns. N minus 1. Now, a lot of you, y'all know, some of y'all invented this stuff, but some of you have had it and it's just going over, a little bit at a time. So let's go ahead and find, these are the things that I'm going to ask you on a test from your calculator. So let's go back to the calculator. And let's find the left. We read from left to right. So I'm going to find this left X-intercept. So second, trace, 0. And remember, I would not, make sure you jump to the other. There we go. Don't hold that button down, because if you hold that button down, it's going to go crazy. At least this one does. And there is my... All right, write that down, negative 5.2. So that one's crossing at 5.2. Negative 5.196. Now what's next? The max. Now, why is this called the max? Why am I not calling it local max? Because this max is the highest point. Can't count this point because the line keeps going. This is your highest point. And this is your lowest point. And you'll see in a few minutes the difference between a local max and a local min and a min. So let's go to second, trace, and go to the max. It really doesn't matter which one you pick because it pretty much does what. And why isn't it going? Okay, I'm trying. There we go. There's left. There's the right. And this is a guess. And that local max is negative 3 and 54. -3, 54. And then we got to find the min. Second, trace min. And jump over to the pink one. Enter. Enter. And there's the local min, or I'm sorry, the min, which is 3, -54. And then now it's time to find the X-intercept. And we got X-intercept with 0, 0 right here. I'm just going to draw this, and I'm going to draw this in pink, just so we'll have it to compare with, even though it's not really a good drawing. There we go. And then the X-intercept right here. And second, trace 0. And jump over to the pink line. And there is the left. There is the right. And there is the guess. And that is 5.196, 0. And that is what you should be able to give me on a test. Okay? Now, they're going to be a little bit more challenging, but it's on the calculator, so it's not like you're going to be, you know, the calculator, all you got to do is type it in correctly, okay? So let's look at another one. And where is the other one? There we go. And you can see they're going for the local max, the max, the min, and the X-intercepts should be in there somewhere. There's the X-intercepts. Okay. Blah, 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 blah. That's where I'm looking to see. Okay, let's graph this one. I'm just going to graph it, and where X is the number of years after 1960. So F is the number of years after 1960. So we go to our handy dandy calculator, make it smaller, move it over. Well, I'm going to just let y'all write that down. I'm going to have to write it down because I can't fit the calculator in there on top of it. So Y is equal to -0.0000597 X cubed plus 0.00934 X squared minus 3.308 plus 5.63. And we're going to put that in the calculator. And I'm going to clear this one. And I'm going to clear this one. -0.40, 1, 2, 3, 4, 597 X cubed. Now, I do realize that there are people in this classroom that invented the calculator. I do realize that you could probably spin it around on your finger like a basketball, basketball. But there are some in here that really suck at it. So that's who I'm trying to help right now. X squared. Minus 0.308, like in the gun. Oh, I'm awful, aren't I? That's awful. I said good. X
762 by 51
plus what?
762 by 51,
Oh,
308.
be quiet. Don't you dare say 7.6. Don't say that. You're a terrorist. Graph. And of course, you can't see hardly anything, so we're going to zoom out a little bit. And you can use the window if you want to. I don't like using the window. I like using zoom out so I can see what it looks like. And I'm going to zoom out again. And then when I get to a view that I like, then I zoom box so I can see it a little bit better. Okay, it didn't like that. Let me try it one more time. Zoom out and enter. There it is. Now, what do you need to find here? Well, you don't really have a max and a min. So the only thing you can find here is your X and Y intercepts. So I'm going to zoom box, and I'm going to try to just get the X and Y intercept in. So maybe here. And don't hold down the key, whatever you do. And enter. Oh, we got some hidden behavior here. What the heck is hidden behavior? That's when you think something is flat, but it's not. And this is not flat. As you can see, we got a max here and a min here, so we got to get to work. I'm going to blow it up a little bit more. Zoom box. And I'm going to put, since I'm worried about the X and Y intercepts, I know the X-Intercept somewhere is right there. And the Y-Intercept looks like it's, I mean, the other X-Intercept looks like it's about right there.
Priority 1 message
and I missed it. So it may not cross. Let's see. It only crosses, may cross just right there. Let me zoom out. Well, let me go to window. And the X max is 14. So I'm going to make it maybe 5. Let's see what that looks like. Nope. It doesn't cross the X axis there. Crosses right here though. So you got 3 things to get right here. You got a max and a min and an X-intercept. So let's do that. So I want you to find the max, the min, and the X-intercept. I'm going to let you do that on your own. Go ahead and do that right quick.
Gmail.
And happy Monday.
So, second, trace. I'm going to get the min because we read from left to right, and that's over there on the left. Left, right. Don't hit. That's frustrating. And what did y'all get? Y'all get 20.53 and 2.73. Yeah, that's what I got, Hubert. Good. So this min is 20.53, comma, 2.73. I'm writing everything down. Second, trace, max. Hopefully there's somebody in the class that's going, I didn't know the calculator could do all this. I hope somebody's saying that. For one, that means you don't use the calculator that much, which is a good thing. And two, hopefully I'm not wasting people's time. I was hoping somebody would give me some input there, but that's okay. I know that's only a glass of water with a lemon, right? There's my max. Y'all get that? Thank you. 83.77, comma, 10.28. And now let's find the X-Intercept. I'm going to have to extend it a little bit. So let's extend my window max to 125, and that's not what I wanted to do. What did I have that on? Did somebody see 5? And let's change this to 125. And there's my X-Intercept. And let's change that window to -5 so we can see where it crosses the y-axis. Well, how about -10? Hey, looked like it would show us window -15. Don't use keyboard. I can't use the keyboard on this thing. I have to use the mouse. I'm sorry. There. There we go. All right, so now I'm going to go over here and find the X-Intercept. Second, trace, 0. And don't hold the key down, whatever you do. And enter. And enter. And there we go. So 120, comma 0. And of course, this is 5.63. The Y-intercept is 5.63. Well, how'd you know that, Hubert? Well, plug in 0 for X. And this is what you should have drawn in your notebook, because that's your min. This is your max. This is your X-intercept. And this is your Y-intercept. Now, what's good about using your calculator? Well, the good thing is you got this. You got called table. Second, graph. This is a good thing. This basically tells you where all the points are. And you see it's growing just very, very, very small till it gets, then it starts growing a little bit more. That's a little bit, you see why I say don't hit the button? Don't. Go to table set, which is second window, and don't start it there. Start it at 0, because all your numbers are going to be positive, because we're dealing with a word problem here. So hit enter, Make sure that's set on 1 and enter. And second table, and there's your numbers. So we said that X, where X is the number of years after 1960. So what is 2050? Well, that's 90 years, isn't it? So what would 2060 be? Come on now, what would 2060 be?
100.
Thank you for the somewhat communication there. Sounded like you were really into it. 100. So I go to my handy dandy calculator and I go to 100. Now you can either type the value in or you can just scroll down. And there is 100. So the estimated or the predicted population or whatever they're looking for 100 years is 8.53. Okay. What if you want a Y value? Well, you can hit second, trace, and hit value, and hit X is equal to 105 years. And 105 years would be what? 7.15. Now, I know this is going to ask for, I'm going to ask for communication here, but how many of you were kind of rusty on your calculators? Okay, got a couple of hands raised. Okay. Of course, I realize some of y'all invented the TI, but I wanted to make sure I got to some of y'all that didn't. All right, let's see what else we got. Let's see what they ask on this question. Let's see. Well, they asked for the men. There's the men. We got that. Use the model to predict the number of older workers in 2025. Well, what's 2025 from now? There's 2060. We did that one. What's 2025? Somebody tell me what 2025 is from 1960.
65.
Okay, so let's go to the table, or we can type in 65. Let's just type it in. Second, trace, value. You say 65?
Yeah.
65 is 8.68. 8.68. And that should be what they got. Let's see. Oh, they want to do a model. Well, okay. Okay, I don't know. Did they do a graph the data points? Oh, okay. So they want us to do a best fit. So let's do that. Let's go ahead and type these in. This will be 0. Let's see. So this will be 10. So I'm gonna write down the points and we're gonna do a best fit. I thought they were doing something else. And this is just another problem. 10, 3.22, 20, 3.05, 30, 3.45, 40, 4.20, 50, 5.44, 60, 8.24, 70, 10.1, 80, 9.6, and 90, 10.2. All right, let's type those in. I'm going to let y'all type them in right quick, and I'm going to type mine in. Stat. Edit. I'm going to go ahead and clear these two. Clear, enter. clear, enter. $10, $20, $30, $40, $50, $60, $70, $80, $90. 3.22, 3.05, 3.45, 4.20, 5.44, 8.24, 10.1, 9.6, and 10.2. And of course, you could do a stat plot. Second, stat plot, on, and graph. Looks like it's a pretty good fit. We're going to do another, we're going to do a linear, let's see, a cubic. So that would be second, I'm sorry, stat, calculate, and let's go with a cubic regression. And remember, right here, what do we hit? We hit vars, y varies, I'm sorry, function, y1, and let me hit one more thing. Color, let's do a magenta. And graph. Well, I don't see it. I guess it's laying in there somewhere. Let me go through and take this one out. I don't want to, but well, let me do this. Let me change this. Change it to that, a little bit dottier. And I don't see it. Wonder where it went. Let me do it one more time. Stat, calculate, cubic regression, L1, L2, vars, y varies, y variable, function, and y sub 2. I messed up. And let me make sure it says magenta. And graph. Well, it's not graphing it. I don't know why it's not graphing it. Zoom 6 or Zoom 9. Well, it should be graphing it, people. I don't know why it's not. Does anybody have, is y'all's graphing it? Appreciate the input. Thank you. Always nice to have a class to communicate. I'm going to just do, I'm not going to do a color. I'm just going to do vars, y varies, function, and y sub 2, and hit graph. Oh, I didn't calculate it. That's why. Let me try that again. Stat, calculate, linear or cubic regression. I didn't hit the calculate button. That's why. So I'm gonna hit vars, function, y sub 2, and then I'm gonna color it magenta. Give me a second. No, vars, color, magenta. Now I'm going to hit calculate. And now I'm going to hit, I should hit graph, and it should, go ahead and write that down. That would be y is equal to negative 0.59714, or 5.9714. Okay, so that's going to be 4 zeros. Y is equal to negative 0.0000597,138. This is the same thing. Why are they x cubed plus 0.00934 x squared minus 0.30777 x plus 5.63. I believe that's the same thing that we typed in. When they shouldn't, why are they, why are they telling you to punch those in when they give you the formula right there? Oh, well, that's how you do it. And they're telling you right here, quartic function squares off on the bottom. The higher you go. What is the ending behavior with a quartic function? A quartic function is anything f of x equals x squared. It's a beyond x squared. X to the 4th, x to the 6th, x to the 8th, and so on. And the big thing here is your parent graph, x squared. Your x to the 4th and x to the 6th, remember, your ending behavior is going in what direction? Not opposite, but what?
Same.
Same direction. So your ending behavior for an even function is going to be going in the same direction. And this area right here is affected by how high your exponent goes. So the more it goes, the more what? The more squared off it becomes. Like that. Okay? I know this may seem kind of, and there's your turning points, n minus 1. So with a quartic function, if you've got the 4th degree, what's 4 minus 1? 3. So you're going to have 3 turns. 1, 2, 3. Here's your saddle. And this is where you're going to see a lot of ending behavior. I mean, hidden behavior, not ending behavior, but hidden behavior. So let's do this one. Go ahead and I just want you to punch that in your calculator. And then I want you to find everything you can find about that function. Give you a minute or two. I know, it's very exciting, isn't it? Y'all settle down, please. Y is equal to negative, well, I'm going to have to write this out. Y is equal to negative 4 zeros, 1, 2, 3, 4, 752, x to the fourth, plus 0.00589, x to the third, minus 0.156 x squared, plus 1.48 x, plus 11.6. So here we go. And I'm going to clear this one. And I'm going to clear this one. Negative 0.0000 752 x to the fourth plus 0.00589 x to the third minus 0.156 x squared plus 1.48 x plus 11.6. Of course, we know that the Y-intercept is 11.6. Turn off your stat plot. Do a zoom fit. Do a zoom standard. Well, we're going to have to zoom out a little bit. I need to go back and change that to a regular line. And graph. And zoom out. Like I said, I hope some of y'all are learning something on this. There we go. There's your saddle. Now we've got a max, a min, a max, but you got to zoom in to get closer. So I'm going to do a zoom box.
I have a question.
Yes.
How did you zoom out again? Do that one more time.
Okay. You zoom. I'm not going to do it one more time. Well, I guess I can. Zoom
I just
out.
can't get mine to look like that.
Zoom out. And then put your cursor in the middle of where you think it's going to be, like right in there. And then hit enter. And it'll keep blowing up until you get it to where you want it. Now, when you get it to where you want it, you hit zoom box. That's what I do because I can't see those numbers down here, and you can't either. So that's not going to do us any good till we get it, in proportion. So I'm going to make sure I cover my X-Intercepts and my Y-Intercepts. And then you can adjust it. Okay, now I can adjust it, but I don't need to adjust it because I've got everything. All right, now I want everybody, let's see what you're going to find. We know the X-Intercept, the Y-Intercept is what? 11.6. We know that. We know it's got 3 turns because 4 minus, and I'm going to put that in, I'm doing this over here. This is stuff that we know. 4 minus 1 is equal. We know that the Y-intercept is 11.6. And now I want you to find the X-intercepts, the maxes, and the mins. So go ahead and do that. So my X-intercept over here, I'm going to hit second, trace, 0. And I'm going to go over there and let it do its thing. And there's the left, there's the right, and there's my guess. So our X-intercept is negative 4.86. Now, of course, you need to read the directions, and you might want to write that whole number down because they may want you to round to the 4th place or the 5th place or whatever. Now, what's this one called? This one's called the max. What's this one called? Local max. If there is one, we'll have to see if there is one right here because this is the min. Oh, let's see. We might have a min right in here. It might be just one place. So let's go ahead and find that out. Second, trace the max. And I'm going to put the left right there. And the right.
Priority 1 message coming in on secured channel.
Right here. And if y'all wondering why my phone is blowing up, we've had a little bit of, what do you call it? Suspicious activity around our community. And that means somebody's casing out the community, fixing to rob some houses. So we got about 4 or 5 people that have got their guns ready and they're about to shoot, I don't know, shoot now and ask questions later or whatever. So they're texting back and forth. That's why I'm getting all kinds of texts this morning. So we don't have a crime rate out here very much. I guess you can understand why. 7.57, 16.17. Now, I don't know. That looks like a min right here. So we're going to check and see if there's a min right there. Second, oops. Trace, min. And I'm going to put it I don't know, right in there. Right in there. It's kind of hard to see it. And the min is 23.38, comma 13.73.
Hey, I have a question.
Yes.
This is totally off subject, but you just mentioned that you had like suspicious activity in your neighborhood.
Yeah.
That's like where you currently live, correct?
Yes.
So, plot twist, my sister lives like almost right across from you on McClure Road. And I just called her just to give her a heads up. She's just asking more information like what's going on.
Who's your sister?
Her name is Hannah Cox now. She lives at 468 McClure Road with the red metal roof.
Oh.
Yeah.
Wait a minute. You sure it's not McClure Drive? There's a McClure Drive that's closer to town, Whitehall Road.
No, she's next to McLeod School or whatever that school's called.
Okay. All right. Just
yeah,
tell her.
Ask.
Hold on just a minute. How can I do this?
And I'm worried. Well, she's ex-Army, so she has guns and everything, but she also has a 5-year-old. So I want to make sure that
Tell her, just people breaking in. If you will text me, I'll send you the car or a picture of a car that it's a blue Honda, and it's been breaking into houses.
Okay. Yeah. Sorry to interrupt. I just heard you say that, and I'm like, shit.
I can't believe that somebody lives out here that you know. Wow, that's amazing.
I was gonna tell you the first day. I was like, oh, I'm not gonna say anything 'cause that's weird. But yeah, she lives like I think she said that she can probably see your house where she's at. So her husband has the big obnoxious trucks that you talk about all the time.
She lives in the Davis. She lives in the Davis house. He just sold his truck to my cousin.
Yeah. So yeah, I just wanted to ask this again. Sorry for interrupting, but I'll message you really quick.
She doesn't have anything to worry about because there's so much activity up there. She doesn't have anything to worry about.
Okay, awesome.
And she lives right across from my cousin, and my cousin will shoot. You ain't got to worry about that.
All right, thanks.
Yeah, thank you. I'm glad to know that. You got to give me her name so I know what her name is. What's her name?
Her name is Hannah Cox.
Hannah Cox. Okay. Yeah. Okay, that's interesting. Small world. Okay, now the X Intercept. Now I got to get my train of thought. Thank you, Miss Garcia. You need to call her back and tell her, look, if you will text me, I'll send you the picture, and then you can send it to her. But everybody's kind of looking and making sure that, they ain't going to stop by and break into your house.
Right.
All right.
Wait after class so I don't have to interrupt anyone. Sorry.
That'd be fine. And X Intercept 0. Yeah, she don't have to worry about crime rate out here. And I don't see, oops. You got to watch this arrows. I ain't kidding you. These arrows are, does y'all's arrows do that too? You hold it down, it goes crazy. Maybe just mine.
Yeah, mine does.
All right, my X Intercept is 42.34, 42.34 and 0. Now, the reason I'm showing you my paper here, this is what you should be doing when you see a graph. This is what you should be doing. You should count the turns. You should find the Y-intercept. You should graph it, and you should be able to find those before you look at the question. Now, let's go back to see what they're finding, because they could be asking you what happens at X is equal to 5. Or, and in that case, if they ask you X is equal to 5, you go to table, second, table, and you look for 5. And don't hold it down. And there, X is equal to 5. Now, why am I showing you all this on the calculator? Because you don't want to do it algebraically. Because if you did it algebraically, you'd have to do a bunch of long division, and it's just not worth it when you got the calculator. Okay? Question, gripe, complaint. So let's see what else they asked you on this question. Graph the function for values from 0 to 35. I think we did that. Use the graph to approximate the years after 2010 in which the total energy supply from crude oil, OIL, is a maximum, and the year before 2045, in which it's a minimum. We found the max and the min. Okay, we found that. But it says use the graph and to approximate the year after 2010, in which total energy supply from crude OIL is a maximum.
Oh.
Here's the maximum right here. So I don't know. Let's see. What is X? X is the years after what? After 2010. So what's 7.57? That's the year. That's 2017 and 6 months. So I don't know what they want to round to. It doesn't say round. It doesn't say round. So our maximum, if I could show y'all, this maximum right here, if you raise that to an 8, that would be 2018. 2018 or 2017.5 is when you have the max. And the min would be 23 years after 2000. So that'd be 2033, 2033.38 or 2034. Okay. And then they say it is likely that this model can be to project the total energy supply from crude OIL products for long after 2045. Yeah, you could, but it looks like to me it's going to be what? What happens after 2000? Let's see, this is 2052 right here. So I guess all the OIL is going to be gone after 2052. Al Gore said we were going to be all dead by 2000.
That guy's an idiot. He also thought he was going to be president.
Yeah. We're not going to have negative OIL. We saw that a few years ago when we were pumping all that OIL out of Alaska. And y'all remember when the price of gas went down to like below $2 a gallon?
Yeah, like it was 7 months ago.
Yeah. That's because we were pumping all that OIL out of Alaska and Texas and Oklahoma.
Then Joe and the
now we're getting it from the Ukraine and China.
Because of
politicians in Washington D.C. are getting their pockets padded.
Because Joe,
don't dare say anything. It's never his fault. Never
Biden.
his fault.
Dude needs to be put in a mental.
It's never his fault. There it is.
Guy can't even form a complete sentence without.
Can't make a ham sandwich. And there's what I just showed y'all right there. So make sure you know your way around the calculator and make sure you know how to find all this stuff. Capiche?
What do you think about Camel Toe's Memorial Day?
I can't discuss things like that because of blood pressure and not getting tired. Okay? So let's go to something else. Because don't you know, my opinion is not an opinion unless everybody agrees upon it. And if everybody agrees upon it, then it's opinion. If you don't agree with it, it's terrorist and racist. All right, so 6.2. What the heck is that? There it is. There's your ending behavior. We already talked about this, but go ahead and write it down so you can feel good about yourself. We already talked about it. If you have an even function, your ending behavior is going to go both ways. That's even function. If you have an odd function, it's going to go opposite directions. So if I give you a test question, and the test question looks like this. What does x to the third minus 7x squared look like? You're going to go, well, you're going to say that's what it looks like. If they don't ask anything else, they just say, what does it look like? Or what is the ending behavior? You're going to do that. What does 4x squared minus 2x plus 3 look like? And you're going to go ending behavior. What if there's a negative right here? What if you have a negative right here? Then it's going to be opposite. If you have a negative right here, it's going to be opposite. When you have an odd function, opposite direction. When you have an even function, same direction. And that is a test question. I think there's a couple on the test that ask this. Okay? All right, find the cubic model. Here's the ones that I was trying to do with the Excel spreadsheet a while ago. I thought they were doing it. All right, go ahead and put that in your calculator. And I want you to graph it. I want you to sketch it on your paper. And I want you to find the X-Intercepts and Y-Intercepts and all that good stuff. So go ahead and do that. There's you can do it on the Excel spreadsheet. But remember, the Excel spreadsheet is not going to give you X squared. I mean, it's not going to give you the X-Intercepts and Y-Intercepts. I'm going to punch these in while you're punching them in. Stat, edit, and I'm going to delete that one. Not delete, clear it. And I'm going to clear that one. Don't hit delete. $27, $32, $37, $42, $47, $52, $57, and $62. 6.3, 6.33, 6.96, 7.07, 7.52, 7.10, 5.58, and 3.54. Stat, calculate, cubic. Did it say cubic? I think it said cubic, didn't it? Yep. I'm going to go through and do the line. So I'm going to go through here and I'm going to hit vars, function, y sub 1, and calculate. There's your information. I'm going to let you write that down in case you didn't do it on the calculator. And then I'm going to punch it in the Excel spreadsheet. Everybody got it? Now I'm going to hit graph. And look there. There it is. And now you got second table. You got your values that you need
Amazon Shopping.
to ask questions, to answer questions.
Today. One more thing.
Somebody got a question?
Deliveries.
Now we're going to look at the graph, and I'm going to blow out. I'm going to zoom out. And I'm just going to hit it one time. I believe hitting it one time will. There it is. And now I'm going to include all of this. I'm going to zoom box. And I'm going to go up to the Y-Intercept. Make sure I get the Y-Intercept in. Enter. And then I'm going to get the max and the min, or the min. And don't hit that. And there is mine. I'm going to hit enter. And there is what you need. So I'm going to draw that graph. And let's find the Y-intercept. Well, the Y-intercept is what? Oh, we don't know, so let's find it. So hit second, trace, value. X is equal to what? And that is 21.679. 21.679133. And of course, that's 0 for X. Now let's find our min, which is right here. Second, trace. And the min. And I'm going to go down here. That looks like left. The right is right there. And the left, I got 27.73 or 74, comma 6.26. And then the max is going to be right over here. Max. And that's going to be left of here. Right there. In the middle. I got 46.19 and 7.40. And then the X-Intercept, second trace, 0. There's the left. There's the right. And I get 66.78, comma, 0. And that should be what you can get from the calculator. And now, anything you need to find, you can find on the table. Question, gripe, complaint. All right, well, I'm going to show you that one more problem on the Excel spreadsheet. And then we're going to call it a day. So pull up the Excel spreadsheet. And make it small. And there's our points. And pull up the spreadsheet. I'm trying to hurry. I know some of y'all are convulsing. So 27, comma, 32, comma, or 37, 42, 47, 52, 57, 62. 3.54, 5.58, 7.10, 7.52, 7.07, 6.96, 6.33, and 6.3. Highlight, insert, add trend line. We're going to call it a polynomial. Well, maybe a power. No. I don't think you're going to be able to get a good one. Nope. Polynomial is going to be about the best one. And see, you only see part of it. Display, display. And see, it's only going to give you a square. So you're only limited. You might could hit to the third. There we go. I hit polynomial and I went to the third. Is that about what y'all got on the calculator? Somebody look and tell me what you got on the calculator. Somebody. That's all right. I'll just look. Stat, calculate, cubic regression, and calculate. Okay, negative 3.616. No, that's something totally off the wall. No, there it is. 0.000361. 000, because they rounded. All right. Yeah, we got the same thing. But what do you not have on this? What do you not have on the Excel spreadsheet? Somebody tell me what you don't have.
Intercepts.
You don't have the intercepts. You don't have the max, the min, and you don't have a table that you can predict with. So that's why on this section, on these homework problems, you might want to use your calculator. All right, anybody got a question? All right, now you are responsible for working on 6.1 and 6.2 for those 5 or 6 students that do the homework, and they should be pretty simple. Should be calculator or Excel spreadsheet, look at the tables, find the numbers. Capiche? All right, I'm going to shut her down and check the roll right quick.